One of the greatest mysteries about Jupiter has always been its weather systems. No one knew if they were simply surface features or whether they went deeper into the planet. This is a mystery the data from Juno is starting to solve. When we last reported on the mission, I spoke to Leigh Fletcher about what he hoped to find.
If water is part of the story for what's driving this incredibly dynamic atmosphere, then we'd have to understand where the water is located within Jupiter and how much, crucially, how much is there within the planet.
Now we can find out if his question has been answered. Now, water vapour, we were discussing this last time. Has it been discovered? What are we finding out about water?
Well, so water was always the essential thing that Juno was going after, because the theory goes that there should be enormous amounts of water down below the cloud tops of Jupiter. Now, here's the problem. In order to understand the water on Jupiter, you have to have a very precise knowledge of the amount of ammonia that's present on Jupiter. And this is one of the Juno cam images. You're seeing a light-coloured zone and a dark-coloured belt. And this light, fluffy stuff is all cloud material, light being reflected back from clouds, but it's ammonia ice crystals welling up, driven by the sort of meteorology of this system. Now, we think that a lot of this is also being driven by water condensing. So there should be loads of water there. Yes. But the problem is getting the actual abundance of water out is a really tough task. And the Juno team, as far as I'm aware, they're still working on it with the data sets that we've got so far. So watch this space.
Yeah, case in progress.
I promise eventually we'll come back and
ask again.
Yes, absolutely.
Even though the question of water hasn't been answered quite yet, Juno's orbit over the poles has led to an astonishing and unexpected discovery.
The key thing was the vantage point, okay? We're zipping in high over Jupiter's clouds and coming down over the polar regions of Jupiter.
Which had never been seen before.
Never been seen before. And in fact, if you had looked at a map 2 years ago, and probably if we did this, you would have seen a bland, greyish area over the pole. Juno has revealed that in all of its glory. So you can see here in this beautiful montage from one of the citizen scientists, the belts and zones up at the high equatorial regions give way to this turbulent, chaotic environment down towards the polar regions. If we start to look in infrared light, which is something that Juno is capable of doing, it reveals something that nobody expected. Let me show you what that looks like. This is the North Pole of Jupiter. And Jupiter sports a crown of cyclones up there at the North Pole.
So this had never been seen before?
Nobody had ever seen this before, and nobody expected to see anything quite like this.
Wow.
So the North Pole of Jupiter throws up some surprises. The South Pole of Jupiter doesn't want to be outdone. And here we go on the South Pole of Jupiter.
So quite different.
Quite different, but not an octagon, a pentagon of cyclones. A pentagon of cyclones that is slightly offset from the poles.
So how dynamic is it? Does this structure stay?
It's actively changing, but funnily enough, these cyclones seem to stay roughly in the same place.
So I guess this is an infrared image, so this is sort of a colouring, just to show us the details.
So where you see bright yellowy red colours, that's warmer. Where you see dark colours, that's cooler. And it's actually more to do with the amount of cloud there than the temperatures themselves. So think of this as dark regions as being cloudy and bright regions as being less cloudy. So you get all this beautiful internal heat sort of welling up. Radiating away from the South Pole of Jupiter.
For Leigh, knowing what's happening beneath the clouds is critical to understanding Jupiter's inner structure and how it formed. In terms of Jupiter's weather, you were trying to investigate how deep it goes, because it is very violent. Have you made any discoveries?
What we're trying to do here is try to understand whether the stuff we see on the surface actually penetrates deep down into the planet. There were two competing theories. The first was that all the weather is really confined in a tiny little layer
like a
on
shell.
top. Like a little shell on top, the skin of an apple, if you like. And in the interior, nothing was necessarily happening. The second theory was that those winds penetrated way, way down into the centre of Jupiter. And Juno has revealed the answer to which of those two theories is correct.
Which one?
And the answer is both of them. Okay, what happens is we now have this picture of the meteorology, the weather and the winds and the convection, all the great stuff that we normally see happening in the top sort of 3,000 kilometres or so. Then down at around about 3,000 kilometres, it gives way to this more solid body, uniform rotation. And that is a definitive Juno discovery. You could only have that discovery with a spacecraft present at Jupiter.
So the data that we've got from Juno so far, does it tell us anything about planetary formation?
What that's telling us is that our ideas that the planets form by the collisions of small planetesimals that build up gravitationally over time, then get to a certain critical mass and suck in all the hydrogen and helium from the solar nebula. We now have measurements of what the insides of Jupiter is like. And we know for the first time that there is a fluffy core down there in the centre.
A fluffy core?
A fluffy core, which means that our ideas of core accretion as the formation of the planets do seem to be accurate.
Well, Leigh, you have delivered. Juno has really come up with some fantastic pictures, but also some fantastic science. And the great thing is there's more to come. So do come back and fill us in on the latest results.
Be delighted. Be delighted.
Thank you.